Good morning, students. Today we are going to look at the session related to page and frame replacement algorithms. And we have done a very small problem in the previous class. I would like to do it with reference to the following strings given today. So let me take the strings 7012003042030321201701701. So there are three kinds of page and frame replacement algorithms. One is the first in first out algorithm. The second one is the optimal algorithm, and third one is the least recently used algorithm. That is the LRU algorithm. Let us see the first in first out algorithm. So let me take the initial pages to be 3 frames. You could see here we have 3 frames. So 1, 2, 3 here. So initially the frames are kept as empty. So when the value of 7 comes, it can able to directly enter into the page frame. Again, when 0 comes, 0 can also enter into the next frame. When 1 comes, one can also enter into the next frame. But you could see the fourth frame is 2. When 2 wanted to enter, the page frame is already full. There is no space here. So now I need to go for the replacement. So the process here is I need to select a victim bit, then I have to go for the replacements. Now you could see here, I have two. So because this is a first in, first out algorithm, what comes first? 7 comes first. So I am going to replace 7 by 2. Hope you understood. Now the next string is 0. You could see here, actually the page frame is already full, but one thing is 0 is also already available. So let's not worry about it. Let's go to the next string. So the next string is 3 here. So check whether 3 is available. 3 is not available, and the page frame is also full. So what you need to do is you have to look at the first bit that is entered. So you might have a confusion here whether 0 has to be replaced or 1 has to be replaced, but definitely it is 0 because 0 is the one which comes first when compared to the bit 1. So 0 should be replaced. So I have 2, 3 and 1. So next comes the bit 0. So now you need to check which has to be replaced because 0 is not available here, and I need to check which bit has to be replaced. So again, check which has come first. So after 1, 0 has come first, so 0 has to be replaced. Okay, then comes the bit 4. So 4 is not available. Now you have to check which bit comes first. So out of this 2, 3, 0, 2 comes first, so it is replaced by 4. Again, I want to go for 2. Here again, first in first out. Which comes first here? 3 comes first, so it is replaced by 2. Now again, I'm going to check 3. 3 is not available, so I have to find the victim bit. So find out which bit needs to be replaced. I could see here, so 0 is the bit which has come first. So replace the bit 0 and I can replace it with 3. Again, the next bit is 0. Check whether 0 is available. So 0 is not available, so I have to find out the victim bit. So the victim bit here will be 4, so I am going to replace it by 0. Again, I am taking 3. 3 is already available. I am going to take 2. 2 is also already available. I am going to take 1. 1 is not available, so I need to replace. So which has come first? So already 2 has come first, so replace it by 1. Again 2. So we need to check whether 2 is available. 2 is actually not available. So I have to find out the victim bit. So the victim bit will be like, the victim bit is like 3 because 3 is the one which comes first. So I'm going to replace it by 2. So now 0 and 1. 0 is available, leave it. 1 is available, just leave it. So I need to check for 7. 7 is not available. The first bit which has come is 0. So replace it by 7. Next I need to replace 0. 1 has come first, so 0. And then I have to check for 1. 1 is not available. So 2 is the bit which has come first. So replace it by 1. So this is how we need to work on the first in, first out algorithm. Now, I would like to find out the page fault. So you all know that the page fault is the one whenever there exists some changes in the pages. Okay. Now, this is also a change in the page. This is also a change in the page. This is also a change in the page, and so on. So what I'm going to do is I'm going to count this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So according to this problem statement, the number of page fault is 15 page fault. Hope you can understand this. Only confusion you will get here is when there is a second digit which is coming, then you have to take the you'll call for a confusion here. So you could find out that whatever comes first should be replaced. Okay, don't worry about when it comes, whether it is the second time it comes, whether it is the third time it comes. Doesn't worry about it. Okay, so whenever it comes in the first time, it has to be replaced. Okay, the one problem which is with respect to the first and first out is, even the next bit is going to be the same bit, we are going for replacement. Okay, in order to overcome that, I'm going for a next level of algorithm which is called as an optimal algorithm. Okay, now we'll solve the same problem for optimal algorithm. So take this same strings and we are going to do it in the optimal algorithm. Okay, let me take initially all the frames are empty frames. So I want to insert 7. 7 can be inserted because the entire pages are free. I'm going to insert 0. 0 can be inserted because it is available. 1. 1, the space is available, I can insert 1. When it comes to 2, when it comes to 2, it will come and check for the page frame. Definitely there is no space available. So how you need to work is, you need to find out a victim bit, right? Hope you all understand what is a victim bit. The bit which is going to be replaced by the new bit is called as victim bit. Okay, so now I'm going to replace this. So here you could go in this level, okay, and find out which number has to be replaced. So which is coming farthest. Find out here. There are two different kind of algorithm. One is the optimal algorithm, another one is the least recently used algorithm. So either you could check in this way or you could check this way. Optimal algorithm aims at the futuristic strings. Now you could see here, when is 7 coming? 7 is coming in the farthest level. Okay, so I'm going to replace 7 here. Okay, 2, 0, 1. Hope you are understanding. Optimal is the one which is immediately going to be used in the future will be maintained, and the one which is going to be used in the later stages will be replaced. Okay, I'm not worried about the bit which is going to be used at the last minute. Okay, I am worried about the bit which is going to be used recently. Okay, now when I compare to 701, 0 is available nearby. 1, 1 is also available nearby. So the only bit is 7. 7 is in the farthest level. Hope you can understand. Okay, now I'm going to change this bit. If there is any doubt, I think someone who understood can pause this video and help your classmates to understand. Okay, let's go for the next bit. 0. 0 is already available. Let's not worry. and the next bit is 3. Now there is no 3 available, so I need to find out the victim bit. So how do you find the victim bit? Yes, you need to find out the farthest level. So take 2, 2 is available here. Take 0, 0 is available here, leave it. Take 1, when compared to 2 and 0, 1 is the farthest. So what I'm going to do is, I'm going to replace this 1 by the new. I hope you students have understood the optimal algorithm, which is going to find out the future string and that is going to be replaced. Okay. Now there may be a question: why do you consider only the future strings? Why not the past strings? So in order to answer the question, we are going for the next algorithm called as least recently used algorithm. Okay. Now let's work on this. We are going to have the same frame 7 7 to be inserted because it is empty. Now I'll take 0, 0 is inserted here, it's empty. I'll take 1, okay, 1 is inserted. Now when I want to insert 2, you are going to check the past history. Now which is available in the farthest in the past? 7, okay. So 7 to be replaced. Now you take 0, 0 is available. Now you take 3, 3 is available. Now you take 0, 0 is available, leave it. Now you take 4. 4 needs to replace a bit which is farthest in the past. You could see here what is in the far past. 0. Here we have 0, 3 and 2 is in the farthest. So I'm going to replace it by 4. Now take the bit 2. Check in the farthest. So I have 4. I have 0. I have 3 available in the farthest. Okay. Replace it by 2. Now take 3. You can find out 2 is here, 4 is here, 0 is here. Replace it by 3. Now you take 0. What is in the farthest? 3, 2 and 4. So replace it by 0. 3, 3 is available here. 2, 2 is available here. 1. Again take the farthest, which is farthest, 2 here, 3 here, 0 here. Replace it by 1. 2, 2 is available here, 0, 0 could be available somewhere here, so it can be replaced by 3. So 2, again we are going to have 1, 1 is available, 7, so we have to look in the farthest one, 1 is here, 0 is here, 2 is here, so replace it by 7. So 0, 0 is available here, 1 available here. Now you need to calculate the page frame. So how will you calculate the page fault? The changes that happened in the pages will be called as a page fault. Even if it is empty, it is full, doesn't matter. Okay. So find out this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So we have 12 page frames. Now you can compare FIFO with an optimal algorithm with least recently used algorithm. So which is having the better, lesser page frame? The optimal has a lesser page frame. Okay. So here optimal works on the future and least recently used work on the past. Along with that, there are some more algorithms called as counting algorithm. So there are different types of counting algorithms. Most frequently used algorithm and least frequently used algorithm. You need to count the number of times the bit appears, and based on the counting, you are going to go for the replacement. Okay. So we are going to work only for first in, first out, optimal and least recently used algorithm. Hope you have understood. We'll go for the problem now. This is the problem statement. You're going to enter this page string. Somebody in the class asked that how the question will be. And this is how the question will be. And how many page faults would occur for the following replacement algorithms, assuming the frames 1, 2, 3, 4, 5, and 6 and 7. Remember, all frames are initially empty. So your first unique page will cost 1 fault each. Doesn't matter whether the page is full or not. Even when you insert it in the empty page, it is going to be considered as a page fault. Now you're going to work for LRU, FIFO, and optimal replacement algorithm. So the next question given here is justify for Belladie's anomaly. So when do this Belladie's anomaly exist? Even when there is in the increase in the page frame for the same set of reference strings, the page fault would be increased. In that case, it is called as a Belladie's anomaly. Very simply to say, when there is an increase in the page frame and increase in the page fault, then we call it as a Belladie's anomaly. Let's do this problem for considering 3 frame, 4 frame and 5 frame. Take a string, work it out for 3 frame, 4 frame and 5 frame. Find out the page fault. Work, take the next algorithm, do it for 3 frame, 4 frame and 5 frame, calculate the page fault. Take the next algorithm, optimal replacement, work it for 3 frame, 4 frame and 5 frame and check the page fault. Okay, even when there is an increase in the page fault, when there is an increase in the page frame, then it is called as an Belladie's anomaly. Okay, so once you have done, this is going to be your solution. Let's not worry about the solution. So start working on this problem. Any doubt, you can clarify. First in, first out, first frame to be replaced, optimal, the last one in the future to be replaced, and in the least recently used, the past one in the last one in the past will be replaced. Okay. So hope you can solve this problem. Once you have solved this problem, just share the answers with me, okay, through the WhatsApp. After your class is over, you can share all the stuff to me. I'll verify and get you the answers. Okay. Thank you. So this is how the counting algorithms. Least frequently used algorithm and most frequently used algorithm. Let's not worry about this. Okay. We'll work on the first in, first out, optimal and least recently used algorithms. Okay. Good. We'll stop here. Thank you.